So nice. Hi, everyone. I'm Kalen Hassler, and today I'm going to be talking about how we designed the Optic portable laser cutter, and I'm going to be getting into sort of the rationale around it. There we go. So laser cutting is this incredible technology that allows you to cut with computer-aided precision whatever you want out of thousands of different materials, whether they be plastic, whether they be wood, paper products, or really anything in between. And you can make whatever you want out of these items, from finished objects. Oh, no, it's not going to show up. Well, like finished objects all the way on the right, or more sort of prototypes or architectural models that you'll see on the left. And this technology is incredible because not only does it allow you to make new objects, you can also customize the objects that you already have. So it's really good for beginners to get into this process as well, as a way of sort of getting into CNC technology and CNC education. And the size of this market is just incredible. There's 1.5 million makers, roughly. I know that's difficult to estimate, but from all of the different YouTube channels and online communities, there's a huge amount of people in the world that are creating things and who would like to be creating things with these machines and other types of machines, whether they be 3D printers, CNC machines, or laser cutters. But these machines have a little bit of, they're a lot more difficult to get your hands on than things like 3D printers, inkjet printers, and other sort of more common CNC machines at this point, because traditionally there can be really large, cumbersome, expensive. They require expensive maintenance, expensive add-ons, high voltage power supplies, water coolers, all these different sort of things that you would find in an industrial environment, which doesn't necessarily make it conducive to rapid prototyping. And so that's why we've designed the Optic portable laser cutter, to be a complete sort of rethink and redesign of what digital prototyping and rapid fabrication can actually be. And so we've looked at all of the aspects of laser cutting as they currently are, and really tried our hardest to systematically remove all of the things that suck about laser cutting right now. This video is a little bit laggy, but I think it's getting the point across. So by taking a look at laser cutting as a whole, sort of taking it apart and pulling out the things that are essential to the process, we've come up with the design of the Optic portable laser cutter. And so it is a fully functioning and precision CNC laser cutter with a build volume of 12 by 18 inches that you can fold up and put out of the way when you're not using it, effectively allowing you to have the tools of like a makerspace or a university right at your desk, whether you're at your home, at your office, or at your desk in school. And so here is just an example of what the Optic looks like when it's actually being used. So you can have it put away when you're not using it, and then when you do actually need to, you can very quickly take it out and use it for your projects. Here, one of our beta testers, he's a printmaker in DC, and he uses the Optic to create printing blocks for his machines. Here's another example where you can use the Optic to actually completely prototype a wholly new product. So here we see a macro pad that was designed in Fusion 360. The keycaps were engraved on the Optic, and the plastic pieces itself were engraved on the Optic. And so you're able to create an entire prototype product just using the Optic portable laser cutter. Here's another use case of actually customizing a pre-existing object. This is a very common use case for laser cutting because you can put pre-existing objects in these machines and then engrave on them and customize them for a variety of purposes. We have a 2-to-1 pricing advantage over our closest competition, and that's including the filtration. And so the next one up is the Glowforge, which you can see we still have a huge advantage over in terms of the amount of like laser cutter to available build volume. And the reason that we were able to do this was because we looked at laser cutting as a whole, and we figured out that by keeping sort of the main components, so the x-axis and the y-axis, having them be independently enclosed, it allows us to actually have a design that can be incredibly compact, because we sort of take those axes and then separate them at a point, at a hinge point, and that allows us to have a very compact machine while maintaining an incredibly large build volume once the machine is actually deployed. And this architecture allows us to do something that no other laser cutter currently has the ability to do, and that is to have fully integrated filtration. And so what this means is that you can use the Optic in any situation, in any location, without the need for an industrial-style air scrubber or having a tube and evacuation system. Did that play? Are you going to play? Doesn't look like that it is. It wants to do it. There we go. And so one of the main advantages of taking the design and individually enclosing each of the axes as opposed to closing the entire box is that allows us to have integrated filtration within the x-axis like this, making it so that you can use the Optic in locations where you couldn't previously have access to laser cutting because you didn't have access to a window or the funding slash space for an industrial air scrubber. And the Optic uses these replaceable cartridges, sort of like a Brita water filter, in order to keep this process easy and simple for the user. And since we've tried to make the Optic as accessible and available as we can, if you do already have a pre-existing air filtration system or an air removal system, there's a secondary kit which would allow you to use it in those situations as well. The next sort of biggest improvement over traditional machines is that the Optic has a cutting mat on it, which actually has engraved alignment and a graduation grid on it, which allows you to precisely line up your artwork if you're working with pre-existing objects or if you're working with size constraints within your material. But what's really cool is that we actually built in the ability for you to remove the cutting mat entirely. This was a little bit later in the design stage after we figured out how easy we could make it to remove the cutting mat. This offers you a few unique advantages, like being able to tile out your design across multiple sizes. And this allows you to do things like this, where you can have a design that stretches across a theoretically infinite area. And then with the relationship between the Optic and the host software, it allows you to quickly retile your design in order to cut objects larger than the Optic. And that same ability to remove the cutting mat also allows you to place the Optic on top of pre-existing surfaces, which is something that you wouldn't be able to do with any sort of traditional machine. And so there's a lot of huge advantages when it comes to giving laser cutting a new architecture like this. But in order to make that work, we had to sort of redesign how our laser in our machine was going to work. So traditionally, these laser cutters use CO2 laser tubes, but then they're constrained by the size and the nature of those types of lasers requiring high voltage power supplies. So what we actually do with the Optic is we created a custom visible light laser, which allowed us to pack the power of 2 diodes in an incredibly small area and then combine them to get the highest possible power laser and the smallest possible form factor. And to pair with the rest of the machine, we wanted to eliminate the need for host computers or high voltage power supplies. And for that, we elected to use USB Type-C for both the power side of the machine and also to connect it to your tablet or your phone or your computer. We wanted to make sure that we made the Optic as future-proof as possible, but also safe. And so there are, on the low end of things, lots of sketchy sort of import laser cutters that don't have any safety features, and we wanted to make sure that we were creating as safe a machine as possible. And so we built in multiple interlocks within the safety shield and other locations in the machine to make sure that it is just as safe and efficient as your other industrial options. And so here you see there's a heat sensor, which will stop the machine in case it is ever overheating for any reason. And for all of those combined features, you can read more about them on our Kickstarter page, which we launched at the beginning of this week. And we were fully funded in 90 minutes for our $50,000 goal, and we doubled that about an hour later, and we're now at, I can't read, 400,000 as of, I don't know, when I put the screenshot in, which was about an hour ago. So yeah, I'm gonna, with any other time, have questions. So this was sort of the design and some considerations around the Optic Portal laser cutter, which we started here 4 years ago and have been helped by everyone and multiple people in the community. And so we are very blessed and very lucky to be here.
Caleb, can you talk about your team?
Yes.
And the process of
Yes.
it, of how'd you get here?
Yes. So when I first got to Virginia Tech, I was studying industrial design and was incredibly excited about all of the opportunity to get to play with these types of machinery and prototyping equipment, whether they be CNC machines, laser cutting, or 3D printing. I fell in love with laser cutting, and because I had built some 3D printers in the past and been sort of a part of that making community, I was like, I can build a laser cutter. It's really easy. It was not that hard to build something that could sort of shoot light at a piece of paper and draw things, but I thought that there was a huge amount of potential in democratizing laser cutting as a process. Shortly thereafter, I met Martin, and we together started working on this, and we applied for some ICAT grants. We got connected to some professors in the School of Architecture that helped us by bringing us to Architecture Exchange East, various conventions, which helped us to do a lot of incredibly important customer discovery. So we talked to lots of architects, artists, and independent designers, and really tried to soak up as much information that we could on their workflows and what they needed out of a machine. And then from there, we built more prototypes. We applied for a competition at the Corporate Research Center that got us a free year of rent at the CRC. It allowed us a little bit of money to buy some CNC machines so that we can begin doing our development off campus. We did a lot of pitch competitions, both here at the university and other outside ones. And we really just kept prototyping and kept engaging as many people in the community, both for help and advice on our startup and help and advice in the actual laser cutting community, figuring out what people wanted. And then we continued to build our team. We were a part of 2 accelerators. We were introduced to Mike Abbott, and we were a part of the RAMP accelerator, and were coached by Mary and all the incredible people over at RAMP. We did Lighthouse Labs as well, so we did 2 accelerators. Both were incredible. And since then, we'd really been building out the machine and finalizing the details around assembly, manufacturing, testing, certifications, all of the sort of tedious work that goes into preparing a product to be manufactured. And then we created all the assets for our Kickstarter, and we launched it. So that's really shortened version of everything up to this point.
And has it been a good week for you?
Has it been a what?
Has it been a good week for you?
It has been a fantastic week. Yes, it's incredible that people actually want this machine that we've worked so hard on and for so many hours on. Feels really good.
Great. What questions do we have from the audience? And if you're online, please put those in the questions link, and I will get right to you. Caleb, what are your Wait. Hold on. hold on. I'll come to you in just a minute. I got one here, but I got to do the mic so they can hear you.
How many hours collectively do you think you've worked on the Optic?
A lot. I 4 times 365. It's been quite a while, and not just me. It's been a team of various sizes and incredible designers and engineers and advisors that have really made all this possible. So I'm sorry, I don't really have an answer to that. A lot of hours.
All right.
So when you started, it seemed like the goal was to develop both a company and a product. And
Yes.
You've spent all this time on this product, which is amazing. I'm curious, I know it's like hard to be thinking way ahead, but what are the goals for the company? Are they around lasers, or are they around technologies or fabrication? How do you see the larger brand? Now that you've had some success, where do you guys want to go?
So we obviously want to build out the Optic and everything around the Optic first. We have some cool accessories that we're working on, which we'd like to sort of put through the development pipeline and get those all the way done and on our site as well. But then we really just hope to be a company that takes these complex technologies and just tries to make them as user-friendly and accessible as possible, because we believe that the world is better when more people have access to a tool and a technology, and especially considering the importance of CNC and robotics and all aspects of our lives, we just want to create tools that allow that to be more accessible to individuals, so that you don't need to be a part of a makerspace and you don't need to outsource your designs, that we're giving the people the tools to do exactly what they need there. So we would love to work on other machines in order to make things more accessible, So we see sort of desktop robotics as the main thing that we want to be doing.
Excellent. What else?
Well, first of all, of course, congratulations. This is just amazing, and the level of design in the product itself. I mean, not just the users but the actual design of the product is just gorgeous.
Thank you.
And I was just curious on the interface side, on the software side, what do people see? How do you actually interface it, maybe for somebody that's never done laser cutting before?
I'm actually just going to go to the Kickstarter page, because there's a fantastic section on that. But there's really a ton of options. Oh, wrong laser cutter. So you have a ton of different options when it comes to creating your designs and sending them to the machine. So the Optic ships with a software called Lightburn, which we have our own custom build of it. So it's taking sort of a standard multi-machine laser cutting software that's used for tons of different machines, and we've adapted it to be really really well integrated with the Optic. And so you can either drag or drop in whatever image you want from the internet or other sort of repositories of laser cuttable files. So you can bring in any image or any vector. You can even just drag and drop them in from Google, and then you're ready to hit the ground running with engraving on top of something. So if you're a total beginner and you just want to customize your laptop, you can just drag and drop in an image from Google, put your laptop in, and then all of the settings are already there for all of the different materials, because we've developed material libraries and specific settings for the Optic. But then if you are coming from Fusion 360, we have a native plugin for Fusion 360 to use the Optic. So you can either use a sort of generalized software where you can bring in whatever vector you want, whatever 2D image, or you can use Fusion 360 and connect to the machine directly to do that. Or really any other G-code sender that you would like to use if you have more experience with Universal G-code sender and Mastercam. The machine just takes sort of agnostic G-code, so whatever works best for your workflow, honestly. But it does ship with a universal software already set up and ready to go with the Optic.
How are you guys navigating manufacturing? Are you guys doing that overseas? How has COVID impacted that? Can you tell me, because I'm sure just designing the machine is one step, and then manufacturing is a whole nother beast.
Yeah. So Some of our parts are coming from overseas manufacturers. A lot of the metal components are being machined overseas. All of our 3D printed parts are in-house in a tiny print farm currently. All of our laser cut components are being laser cut domestically. And so all of these parts are shipped to us, and we are doing the assembly and the testing and the QC and the shipping from our headquarters over at the Corporate Research Center. And so we hope to eventually do more and more sort of contract manufacturing of some of the smaller sub-assemblies of the machine. But for right now, we are just getting all the parts and building them in our own space so that we can ensure quality. And to answer your question about the COVID parts, that has been affecting mostly shipping times rather than availability. And so things are taking longer to get here from the overseas manufacturer, as well as some of the domestic shipping has also been taking a lot longer.
We've got a question online from Ethan, who says this is so cool. First, quick question about shipping. When do you expect the third batch of shipping to begin? I assume there's already a first and second.
The third batch of
That's a very
shipping.
specific question.
I will have to check on the reward tiers. The third batch, estimated delivery January 2023.
Okay.
The one before that is October 2022, and the one before that is September 2022.
Sweet. How much fun is this to get to watch a Kickstarter like go?
Yeah, what are we at? What are we at now, actually? Oh, lost it.
What other questions do we have in the room?
Caleb, you said initially it was very easy to shoot a laser at a piece of paper and cut it, but I'm sure in the last 4 years you hit a few bumps and conflict along the way.
Definitely.
Did you ever have a point in time where you thought maybe this wasn't going to come to fruition
Yes.
and we won't pull it off?
Yes,
And
100%.
how'd you overcome it? What was it like?
So it's really easy to get the laser to burn the paper. It's incredibly difficult to take the stuff that it burned and filter it out and make it usable anywhere. And so that was really where the largest amount of research and development went into, was not only creating a laser of this power and this form factor, but then also managing that power on the filtration side and being able to create a robust system that can efficiently, quickly, and cleanly filter out all of the particulate and fumes during laser cutting. And so it took a huge amount of engineering and design to get our filtration system to work. So, because now you can use the Optic just at a table and there's no smoke anywhere. It captures 100% of the fumes created that you can see, that you can smell. And so it's yeah, that was the biggest development hurdle and success.
Excellent. We got time for maybe one more. I'll come up to you.
Now that you've, how many multiplied your goal, and probably will go much higher, are you guys trying to build a team? And maybe there are tech students that might be interested in hearing about that, if so.
Yeah. So we are going to be building out our assembly and our testing and organization all in-house, and so we are going to be increasing the size of our team to bring on more quality talent. So we're looking for quality management and sort of help with us designing our in-house assembly process and in-house testing regimen. And so those are sort of the main things that we are going to be looking for as we expand our team to fulfill these orders. And so if any of you know anyone with quality engineering experience or quality management experience or other, generalized product engineering like this, it'd be great to send them our direction.
Wonderful. Well, we're taking full credit, and we've said for a while we're probably going to all end up working for Caleb one day. So, Caleb, thank you so much for being here today. This is wonderful, and what a great story to tell, an ICAT story for the ages. Thank you all for being here today, both in the room and online. Thanks for being here. If you have PDN questions, of course, let me know, and we'll see you next time, next Friday, same time, same place. See you then. Thanks.
Thanks so much, everyone.